Kingfisher. The common kingfisher, Alcedo athis, also known as the Eurasian kingfisher and river kingfisher, is a small kingfisher with 7 subspecies recognized within its wide distribution across Eurasia and North Africa. It is resident in much of its range, but migrates from areas where rivers freeze in winter. This sparrow-sized bird has the typical short-tailed, large-headed kingfisher profile. It has blue upperparts, orange underparts and a long bill. It feeds mainly on fish, caught by diving, and has special visual adaptations to enable it to see prey underwater. The glossy white eggs are laid in a nest at the end of a burrow in a riverbank. Description: this species has the typical short-tailed, dumpy-bodied, large-headed, and long-billed kingfisher shape. The adult male of the Western European subspecies, A.A. aspida, has green-blue upperparts with pale azure blue back and rump, a rufous patch by the bill base, and a rufous ear patch. It has a green-blue neck stripe, white neck blaze and throat, rufous underparts, and a black bill with some red at the base. The legs and feet are bright red. It is about 16 centimeters long with a wingspan of 25 centimeters, and weighs 34 to 46 grams. The female is identical in appearance to the male except that her lower mandible is orange-red with a black tip. The juvenile is similar to the adult, but with duller and greener upperparts and paler underparts. Its bill is black, and the legs are also initially black. Feathers are molted gradually between July and November, with the main flight feathers taking 90 to 100 days to molt and regrow. Some that molt late may suspend their molt during cold winter weather. The flight of the kingfisher is fast, direct and usually low over water. The short, rounded wings whir rapidly, and a bird flying away shows an electric blue flash down its back. In North Africa, Europe and Asia north of the Himalayas, this is the only small blue kingfisher. In South and Southeast Asia, it can be confused with 6 other small blue and rufous kingfishers, but the rufous ear patches distinguish it from all but juvenile blue-eared kingfishers. Details of the head pattern may be necessary to differentiate the 2 species where both occur. The common kingfisher hunts from a perch 1 to 2 meters above the water, on a branch, post or riverbank, bill pointing down as it searches for prey. It bobs its head when food is detected to gauge the distance and plunges steeply down to seize its prey, usually no deeper than 25 centimeters below the surface. The wings are opened underwater and the open eyes are protected by the transparent third eyelid. The bird rises beak first from the surface and flies back to its perch. At the perch, the fish is adjusted until it is held near its tail and beaten against the perch several times. Once dead, the fish is positioned lengthways and swallowed head first. A few times each day, a small grayish pellet of fish bones and other indigestible remains is regurgitated. A challenge for any diving bird is the change in refraction between air and water. The eyes of many birds have 2 foveae. The fovea is the area of the retina with the greatest density of light receptors, and a kingfisher can switch from the main central fovea to the auxiliary fovea when it enters water. A retinal streak of high receptor density which connects the 2 foveae allows the image to swing temporally as the bird drops onto the prey. The egg-shaped lens of the eye points towards the auxiliary fovea, enabling the bird to maintain visual acuity underwater. Because of the positions of the foveae, the kingfisher has monocular vision in air, and binocular vision in water. The underwater vision is not as sharp as in air, but the ability to judge the distance of moving prey is more important than the sharpness of the image. Each cone cell of a bird's retina contains an oil droplet that may contain carotenoid pigments. These droplets enhance color vision and reduce glare. Aquatic kingfishers have high numbers of red pigments in their oil droplets. The reason red droplets predominate is not understood, but the droplets may help with the glare or the dispersion of light from particulate matter in the water. Thanks for watching.